Okay, let's talk higher order derivatives. So we now know how to take the first derivative, which is this first one right here, but we can also take higher order derivatives. So we can take the derivative of the derivative, and that gives you the second derivative, which we usually say is f double prime of x, and it can be written like these as well. You can take the third derivative, f triple prime of x, the fourth derivative, and so on and so forth. So let's try an example where we do that. So we have f of x right here. I'm going to rewrite it a little bit so that our shortcut rule is a little more helpful. So I'm going to write that as x to the 2/3. Write it as an exponent instead of a root so that I can use my rule. And then I'm going to take the 1/2 in front and take my x to the 2/3 up into the numerator so it becomes negative. So now that I have it written like this, now it's a lot easier to take the derivative. So f prime of x, the constant goes out in front. I'm going to bring my exponent down. Excuse me, guys. And then subtract my exponent by 1. So f prime of x is going to be, looks like negative 1/3 x to the negative 5/3. Now I'm also going to want f double prime of x. So while we've got it written like this, let's take the derivative again. So I take the exponent, take it down in front, and then 5/3 minus 1. So f double prime of x looks like it's going to be 5/9 x to the negative 8/3, I think. Okay. Now we actually want to plug numbers into these. It's going to be a lot easier to plug numbers into them if we put it back into root form like this with our positive exponents. So I'm going to take f prime of x, move the x back down into the denominator so it's positive, and then change it into root form. So it should be cube root of x to the 5th. I can do the same thing with f double prime. So 5, move x down so it's positive. And then I'm going to change it back into the cube root of x to the 8th. So there we go. Now I'm going to plug in my number. So I want f prime of 1. So plug 1 into the first one. So negative 1/3 cube root of 1 to the 5th. Now, do we need to simplify that? Nope. Leave it like that and you're fine. And let's find f double prime of negative 8. So this one I've got 5/9 cube root of negative 8 to the 8th. Plugging negative 8 into my f double prime. And once again, I do not need to simplify that. You can if you want. If you have your calculator, you're welcome to. But you don't need to. You can just leave it like that. So that is an example of taking multiple derivatives. In the next video, we're going to talk about equations of tangent lines.